Hello class. Today what we'd like to talk about is four centers of a triangle. Now, first, we would like to look at a triangle, let us say, and let us try to look into centroid. Centroid is in fact uh, intersection of medians. In order for us to draw a median, what we need to do is we need to connect a vertex to its uh, midpoint that is opposite of that vertex. Now, how would you find the midpoint? Midpoint can be easily found by perpendicular bisector construction, that which we have done earlier. So in fact, what we like to do is this: we like to do the perpendicular bisector construction on all three sides, here and here and here, and connect the midpoint to opposite vertex, hence creating the medians. Let's get started. Then first, getting a compass and a ruler, first we got to open the compass just like before, a bit more than a half, and draw an arc. Do the same. Over there. Now, bring when you bring a straight edge, you will realize that midpoint should be around here. So when you connect a vertex to a midpoint, that becomes our first median. Now let us try to do the same with the other corners. This time I'm going to use the blue to sketch an arc on one side and the other, and using a straight edge, we'll be able to draw once again a perpendicular bisector, which gives us a location of the midpoint, and connecting the midpoint with the vertex. There it goes. Another median. So we have two medians so far, one in red, one in blue. Now let us go for the third side right over here. This time I'll be using green, and I have to go more than half. I'm going to open this one up a bit more. Okay, and do the same. Oh, I guess I have to open it up a bit more. Okay, I'm going to open it up a bit more than half. All right, so connecting one intersection with the other, would have given us that midpoint right over there. And I'd like to connect that midpoint with its opposite vertex. Now, then interestingly enough, I want you to focus on this section, right over here in the middle. You see, if I were to take this one out, this perpendicular, if I just leave if I were to take everything out except the medians, of course you cannot do that without construction and without, smart notebook. When you look at the medians alone, you will see that they will be meeting up at one particular point. Now, that's not coincidence. This is, in fact, a special property of the collection of the medians, any triangle for that matter. And we call them medians are concurrent because they meet up at one particular point. And that intersection, right over here, that is called centroid. Now, we will talk about special properties of the centroid a bit later, but we'll continue for the next construction. Next construction is this. Given a triangle, just like earlier, what if you have to draw not just a median, but rather let us stop one step earlier, which is perpendicular bisectors. Essentially, that's what we have done earlier anyway. If you were to draw perpendicular bisectors using a compass and a ruler, you're going to go one at a time, just like before. And moving over to the other side. Oops. I guess we have to open it up a bit more. Now, this time what we like to do is our purpose is not just to find midpoint, but in fact what we want to do is we want to get the perpendicular bisectors, all three of them. So I'm going to extend it a bit more because I have no idea where they'll be intersecting. Now, second, I'm going to go to this corner right over here with red ink. So I can go back here, I guess, and go to the other side, just like earlier. Connect it, then we end up getting another perpendicular bisector. Now, it seems like two of them would have met right over here. Now, let us go for the third one together. Third one, I'm going to use the blue. And I would have to go a bit more than half. I'm going to go more than half like this. Then you will realize another intersection. By connecting those two. But now you will realize the blue one was the perpendicular to this long side. Green one was against the horizontal line, and then yellow, the red one was against this slanted side. But after drawing all three perpendicular bisectors, you will realize that, aha, wait a minute, they're meeting up at one single point, you see, right over here. This one was the one median, green one was another, and then red one was the third one. They're meeting up one single point. Then what is the significance of that particular point? Interestingly enough, mathematicians were looking at that point and realized that, hey, wait a minute, what if we draw a circle about the particular point? Oh, wait a minute. Oh, wait a minute. Oh, look at that. You will realize that that intersection can be the center of a circle that's circumscribing the triangle. Hence, the intersection of the perpendicular bisectors, as we can see right over here, this became circumcenter, meaning the name obviously came from center of a circumscribing circle, hence the name circumcenter. It's quite interesting, isn't it? Now, we're going to move on to the next one. In this case, we are still looking at a triangle, and the question is, instead of cutting the line segment in half, how about, what if we were to cut the angle in half, meaning angle bisectors? Once again, we'll be using a ruler, or the straight edge, and a compass. Now, in order for me to get the half of this angle, first I'm going to open this one up, and let me try to just use the maybe blue. I'm going to draw an arc. This is something that we already have done earlier in the bisecting the angles, and I'll just go a bit smaller. It's okay. And draw an arc. So as if I go over here, come closer, and then draw an arc. Then what I'm end up getting is that intersection, and that intersection in fact can be connected with a vertex. Then you will realize that we have an angle bisector. Now, let us try to do the same with the other two angles, starting from here. Now, I'm going to use the red in this case, and let me try to draw an arc just like before. And go to one edge and one intersection, and draw an arc. Go to the second intersection right here, draw another arc. Then here you can realize another intersection between two arcs. Now when you connect them, you will get second angle bisector, and you will realize that between the blue angle bisector and the red angle bisector, they're meeting around here in the middle. Let us try to continue with green. To open it up just a little bit more, and do exactly the same as before. Around here. I'm going to bring it up. Around here now, intersection becomes right at this point, and once again, just like before, we're going to bring down we're going to bring down the intersection and then the vertex. Now, wait a minute. Did you realize that the red angle bisector, the blue angle bisector, and then green angle bisector are meeting up at right here at this point? Now, so when the mathematicians were looking at this, wait a minute. That looks quite interesting. Can we draw a circle around at this point? Center that at this point. Once you have done that, actually center is a little bit off, but you will realize that a circle can be drawn right at the point. And since the circle is inscribed in a triangle, the center is called in center. In center basically means that we are looking at the center of a center of inscribed circle, and that hence the name in center. That would be our next center. Now, last one would have been this. Let's collect the altitudes. We talked about medians, we talked about angle bisectors, we talked about perpendicular bisectors. One thing that which we didn't get to talk about yet would have been the altitudes. Now, how are we going to get that? First, altitude will be same as constructing a perpendicular line segment from a given point. Getting a ruler right over here. Then, in order for us to do that, just like earlier, what we need to do is first, from a vertex, we need to open up the compass more than half. Now, let me try to use the blue. But wait a minute. In this particular case, what happened was that we the bottom side didn't extend to the other side. Therefore, we don't know where they're intersecting. So therefore, what I'm going to do is, what if I were to extend this line to the other side? Then you will realize that intersection would have been right over here, and it would have been here. So this will be our imaginary line segment, which we're gonna get the perpendicular bisector of this line, or this portion of the line segment, to connect with this vertex, hence creating the altitude. Now, then first, so about more than half, I guess, a little bit. Let me go a bit further. So I'm gonna draw an arc. So is the other one arc, and then when you connect the vertex passing through minimum at least one of each intersection towards the imaginary line, then we will end up getting a blue altitude right over here. Now we gotta do the same from this vertex towards the longest side. We'll do that with red. Once again, go a bit more than half, and more than the distance of the distance between the vertex and then its opposite side, and draw an arc. Now by doing so, we created the portion of the line segment where the vertex will be in the middle of it. Then come through this way, and then I'm just going to narrow it just a little bit and draw an arc. Same on the other side. Now what we can do is, if you connect the intersection you connect the intersection with the altitude, then you will get something like this. Now, in fact, if I were to go up in earlier, if I were to extend this altitude, you would have realized that they will be meeting up around here. Now, let's see what happens if you have to draw another altitude from this vertex. Now, as you can see, for if I were to draw the altitude, then it would have come down somewhere in this direction. But since this line is somewhat limited, what I'm going to do is this: I'm going to extend this side also. All right. Now then, let's get moving. Using green, I will try to. Oops. Using green, I try to get one more portion of the line segment, and doing exactly the same thing as before. Drawing a line segment on the other side right here. I'm drawing an arc. Now we are drawing a line segment. If you connect them, then all of a sudden you will realize that, haha, wait a minute. Use the blue altitude and red altitude right over here, and green altitude, they will all meet up at this particular point. And since these are the collection of the altitudes, which are perpendicular to opposite side, of course, therefore this is called orthocenter. Alright, so that's it for now. But in fact, if you connect orthocenter of a triangle and circumcenter and centroid, we'll end up getting a special line called Euler's line. And if you are interested in, when you research through that, you will find something quite amazing properties and facts regarding a triangle and those centers. All right, we'll finish up now and have a great day. See you soon.